Welcome viewers in my second lecture on automated manufacturing systems. In this lectures, I will discuss about performance measure of automated manufacturing system. What does it mean? It means suppose I have several manufacturing systems, say automated manufacturing system 1, automated manufacturing system 2 and so on. What are the indicative measures that I can compare these manufacturing systems? Actually, there are 8 parameters. First and foremost, it should be manufacturing lead time, then work in progress inventory, then machine utilization, and last and the most important part of manufacturing system is quality. Let me show you a slide. There are 8 performance measure of any manufacturing systems which are indicative status in the manufacturing world. These are manufacturing lead time, work in progress, machine utilization, throughput, flexibility, capacity and quality. Now, first let me discuss about manufacturing lead time, what it consists of. Manufacturing lead time actually the time between the acceptance of the order from the customer and delivery of the finished product to the customer. This is very important, as I discussed in my last lectures. Actually, manufacturing lead time constitute of setup time, process time, move time and queue time. Now, what is setup time? Setup time. It has been observed in any manufacturing systems, if it is automated manufacturing system, that means job is to be produced automatically, starting from the raw material coming to the workstation and the job holding device in the machine itself. So, this setup time is nothing but setup of the job in the working station, setup time of the job in the workstation or machines. It has been observed that at least 15 to 20% time is spent on the setting the job in the workstations. So, how to reduce this time? So, for example, I want to produce a product which needs to be operated in a lathe machine, say for example lathe machine, then in a milling machine. Let me write down the abbreviated term, then boring machine, say for example, and say for drilling machine. So, my job goes to these directions. So, I have to set up the job to the lathe machine. Once this performance is over, then it goes to this machine, then it goes to this machine, then it goes to this machine. So, setup time, total setup time is the summation of time in this tool plus time in this tool plus time in this tool plus time in this machine tool. So, how to reduce it? This can be reduced drastically if I have a machine where I can perform the operations on a single machine of this operation, this operation, this operation and this operation. Of course, in a single machine all operation of lathe machine cannot be performed definitely, all operation of milling machine cannot be performed definitely, all operation boring or drilling machine cannot be performed. It is as simple as that. But most of the common operations, if I can perform in a single machine, then this setup time can be drastically reduced, so that I can produce the product or deliver the product to the customers a bit earlier. This type of machine is called machining center, where, so how I will define this machining center? A machining center is a machine where some operations of milling, where some operation or most of the operation of boring or most of the operation of drilling machine can be performed in a single machine with a single setup. So, ultimate aim of this machining center is to reduce the cost. Of course, the cost of this type of machine is much more than these individual machines, but as I can produce, I can use this machine for the substitution of these machines. So, this cost can be compensated, this cost can be compensated. As any automated manufacturing system nowadays is costly, a costlier phenomenon, costlier in the sense, say for any, if I want to purchase a lathe machine for a production type lathe machine, it costs around 20 lakhs. If it is a milling machine, maybe in the tune of 50-60 lakhs. So, cost is a bit higher, na? So, I should use this machine as much as possible, So, this if I use this machine, I can reduce this setup time. Now, next comes process time. This process time is actual machining time, time. Then then move time. Move time means time between this is the first operation is carried on here, then time between this machine to machine, time between this and time between this, summation of all this time is called move time. Move time. Then comes queue time. Queue time. So, as these are the machines, if some machine becomes out of order or non-functional, you see whole of this system becomes non-functional. So, common phenomenon or common practice in the industry is that I can put some number of parts in between machine, why it is called buffer storage. So, this operation may not be at the some operations it has to wait for this. So, this time is called queue time. Now, what is the what would the if I want to model a manufacturing lead time, what should be the mathematical model of manufacturing lead time? Mathematical model of manufacturing lead time will be mathematical model of MLT. Mathematical model of MLT will be summation of MLT is equal to MLT is equal to summation of SI, I is equal to 1 to n. Actually, this SI is nothing but setup time, S I is setup time, I stands for individual workstation as I discussed earlier, individual workstations, then QI, I discuss what is QI, then TI plus AI, MI plus QI. MI plus QI. So, what is Q? So, here TI stands for processing time, SI stands for setup time, AI is inspection time, QI is waiting time and Q is batch size. What is this Q? Actually, Q this comes what is this batch size? What should be the actual size of the batches? You see, it cannot be a constant number. It cannot be constant number. It depends upon the basically cost of the product and the cost of inventory of the product. Let me show you a mathematical model of this. This Q is basically is equal to root over 2 SD root over 2 S D by I. This S stands for setup cost, S stands for setup cost, I stands for inventory cost. Inventory cost. This is called, actually this is called economic batch size. Economic batch size. Okay. Now, if it is a job shop production, the model of MLT can be simply where job shop production means I can write down Q is equal to 1. So, my MLT will be summation of SI plus TI plus AI plus MI plus UI, as simple as that. This one is your first performance measure. So, obviously, MLT lesser MLT is lesser the better, so that I can deliver the product as soon as possible. The next performance measure is processing time. As I told you, it is the actual machining time. So, these are the model. Now, number 2 performance measure is work in process inventory. Work in process inventory. What does it mean? As I told you that, if a job needs to be operated in different workstations, some buffer storage must be there, so that if any processing stations is non-functional, then from this buffer storage other working stations or processing station remains functional. This is called work in process inventory. So, if the individual working stations reliability is much more, then I can keep these work in process inventory as less as possible. So, that I know that the working stations becomes out of order not very frequently, I know that it is reliable. So, why I should keep much more in between otherwise. So, a good automated manufacturing system should have working process inventory as low as possible, working process inventory as low as possible, because everything is cost. You are keeping the product in between, cost of these raw materials becomes idle. So, your cost of manufacturing eventually becomes higher. The next performance measure of automated manufacturing system is machine utilization. Machine utilization. you see today's manufacturing system is basically a electromechanical system, not electromechanical, it is basically a mechanical system integrated with electronics, instrumentation, computer, so many things. So, it is any automated modern automated manufacturing system can be regarded as mechatronic system. As you know, this system is integrated with so much sensors, so much computer, so much control system. So, reliability of this system or lifespan of this system becomes much lower. Conventional lathe or conventional milling machine, it can be functional years after years, but life of any that mechatronic system or electromechanical systems is very less, maybe in the tune of 10 to 15 years. So, when I invest so much money in a system, in a device, I should expect some return, at least my investment plus profit, some profit. So, within this 10 to 15 years, my return, we call it return on investment, return on investment. So, what happens? Machine utilization should be as much as possible. Normally, what happens in industry, if it is a CNC type of mechatronic system or automated mechatronic systems, most of the industry are working even 3 shifts, that means all 24 hours, only some regular or periodic maintenance is there, otherwise the industry cannot survive, cannot be a profitable business, because of the fact so much so investment is there, plus some skilled labor is there. So, if it is an automated manufacturing system, machine utilization should be as high as possible, otherwise it cannot be a good investment. The third parameter is throughput. The concept of throughput is fairly simple. Throughput is generally expressed as an hourly or daily production rate. The reciprocal of throughput or production rate is the production time per unit of the product for transfer line, and throughput approximates the reciprocal of the cycle time. In case of the job shops, the relationship is not so simple, but could be characterized on the number of units leaving the unload stations per day or per hour. In this lectures, I have tried to discuss some performance measures of automated manufacturing systems like MLT, like machine utilization, like throughput, and what are the components of a manufacturing lead time are what are the components that are also I have discussed. In the next lectures, I will discuss remaining performance indicator of an automated manufacturing systems. Till then, goodbye.